So in this one, I'm just adding fractions together. And if you remember when we add fractions, say we had 2/5 plus 3/4, what we would do is we would find the LCM of 5 and 4, which would be 20. 5 times 4 equals 20. And then we would say 5 goes into 24 times, so it would be 4 times 2. 4 goes into 25 times 5 times 3. So we use the same method for adding algebraic fractions. Okay, so the LCM of 5, 2, and 3, what I'm wanting to do is to put everything over 5, 2, and 3. They might also say to write as a single fraction. So in other words, they're asking you to write it so that there's only one denominator. So 5, 2, and 3, the LCM of 5, 2, and 3 looks like it's 30. That would be 5 times 2 times 3. There might be a smaller one. If you don't get the smaller one, it doesn't matter. You can still use 30. I mean, it's not a problem. So 30 is the LCM. So if you remember from this example just a moment ago, I say 5 goes into 30. It goes in 6 times. So it's 6 by 2x minus 1. There's a minus here that I'm going to keep. 2 goes into 30 15 times by 3x minus 4. There's a plus here that I'm going to keep. And 3 goes into 30 10 times by x plus 5. Okay, now why is that? Well, let's just do a quick why is that. So 6 by 2x minus 1 over 30, which is what this bit here is. If I cancelled those, I'd have 2x minus 1 over 5, which is what I had at the start. So that's why I have a 6 over 30. So 6 over 30 is the same fraction as 1 over 5. That's why it's 6 over 30. 15 over 30 is the same fraction as 1 over 2. And 10 over 30 is the same fraction as 1 over 3. So that's why those numbers are there. And then I multiply out my brackets. 6 by 2x is 12x. 6 by minus 1 is minus 6. Minus 15 by 3x is minus 45x. And minus 15 by minus 4 is plus 60. 10 by x is 10x. And 10 by 5 is 50. So just taking it very slowly there, not trying to do it all in one go, just taking time, and it's still all over 30. So what do I have? I have 12x and 10x is 22x, minus 45x is minus 23x. And then I've got 60 and 50 is 110 minus 6 is plus 104. Now that is a weird fraction, because nothing's going to cancel there. Minus 23x plus 104 over 30. Now because it's so weird, I'm just going to double check that I have things right. So 6 by 2x is 12x, 6 by minus 1 is minus 6, minus 15 by 3x is minus 45x, minus 15 by minus 4 is plus 60, and 10x and 50. Yes, so I do seem to have it right, it's just a weird answer. So that's my answer. That's the simplest form. It's a single fraction. Okay, so that's the first type. The second type is when you've got an actual equation. So in my equation here, I've got 7t minus 1 over 3 minus 2t plus 5 over 6 is equal to minus 3 over 2. Now there's two different ways to do this. I'm sure there's more than two, but there's two possible ways to do it that I'm going to look at. One of them is, the first way is to write as a single fraction and then solve. And the second way is to cancel all the fractions, cancel all the denominators by multiplying. So there's two different ways there. I'm going to do them both ways because both ways work when it's an equation. So it's an equation, so therefore we can do this one. Okay, so let's set it up. 7t minus 1 over 3 minus 2t plus 5 over 6 is equal to minus 3 over 2. So writing it as a single fraction, I'm going to ignore the fact the equals is there. I'm going to keep that equals there, but I'm going to include this side. So my LCM from 3, 6, and 2 is 6. We can see that. 3 goes into 6 twice, so it's 2 by 7t minus 1. 6 goes into 6 once. Now remember, I have a minus here. I'm going to keep it. 6 goes into 6 once, so that's 1 by 2t plus 5 equals, and 2 goes into 6 3 times. So it's 3 times minus 3. Okay, and then I have 2 by 7t is 14t, 2 by minus 1 is minus 2, minus 1 by 2t is minus 2t, minus 1 by 5 is minus 5, and 3 by minus 3 is minus 9, all over 6. So what I have is 12t minus 7 is equal to minus 9, and it's all over 6. Once it's all over 6, if I had x over 4 equals 7 over 4, you'd know that x must equal 7. So once it's over the same fraction, or written all over the same denominator, then we can just ignore the top. So 12t minus 7 is equal to minus 9. I'm going to add 7 to both sides. 12t is equal to minus 2. Divide by 12, divide by 12. T is equal to minus 2 over 12, which equals minus 1/6. And what we can do is, if we want to double check, we can sub that back in on our calculators into our original equation and check that it works. So you can always check if you want to. Now the other way of doing it, and you can only do this if it's an equation, okay, is to multiply across by the LCM. So multiply by LCM. So the LCM here is 6. So I'm going to do 6 by 7t minus 1 over 3 minus 6 by 2t plus 5 over 6 is equal to 6 by minus 3 over 2. And we're going to end up doing basically the same thing. It's just that we end up a little bit less messy maybe. So what do I have is 2 by 7t minus 1 minus 1 by 2t plus 5 is equal to minus 9. So 14t minus 2 minus 2t minus 5 is equal to minus 9. And if you notice, we end up with the same thing. It's just slightly less cumbersome. So t is equal to minus 2 over 12. T is equal to minus 1/6. Okay.